Hello everyone, I welcome you for yet another video on CSAT. In this video, we are going to discuss about yet another important concept of basic numeracy, that is averages. Now we have already done with the number system and we have done with around 12 videos regarding the different concept of number system, and we have solved enough of PYQs also to know what are the kind of questions that are appearing. Now, keeping that in mind and moving forward, we will start with the chapter averages. All right. So, it's a very important chapter because every year you can expect one question. Sometimes you have, got the two questions from this chapter also, but one question is minimum that you can always expect from yearly wise. And a very easy chapter. Once you understand the basic concept, then it is the kind of question that has been asked are pretty much doable. Right. Now, keeping that in mind, let's dwell into the concept. All right. So now, first, let us understand the term averages. Right. What is mean? Right. So averages, also called as arithmetic mean. Arithmetic mean. Now, what is the meaning of it? Right. It is a central tendency where if I can replace all the term by that averages, till our total remains same. What do I mean by it? Let's say if I have an example here, right? Let's say if I have 4 numbers, 1, 2, 3 and 6, okay? Now if I see at it, now the total, the time, let's assume that somebody has scored, in his first 4 innings, first innings he has scored 2, then he has scored 2, 1, then second he has scored 2, then he has scored 3, then he has scored 6. Right? Now that means that the total runs that he has scored is 1 plus 2, 3, 3 plus 3, 6, 3 plus 6 plus 6, 12 runs. Total runs he has scored is 12 runs. Now that means that per match, how much he has scored. If I want to distribute his total run equally among all the matches or all the innings, how much he would be scoring. Right? So that means that there are 12 matches. I have to divide it among how many matches? 4 matches or 4 innings. So I get 3, right? So that means that if I replace is all matches run by 3, still his total score is 12. So that is basically, if you look at the averages is 3, that means that even if he had scored 3 in all the matches, that is as same as is with respect to his total number of runs if he has scored 1, 2, 3, 6 also, right? So that is basically the central number which everything will appear to be, right? So in that way, let's understand, right? So let's say if I see the deviation, right, from the averages. Now in this score, as you know, that average is 3. Now in the first innings he has scored 1 runs, which is basically 2 less than the average. Or see, the second innings he has scored 2, which is 1 less than average. Now in the third innings, he has scored 3 only, that is equal to average. So there is no deviation, that means that 0 deviation. Now here it is 3 more than the average. So if I add the deviations, how much it has, each individual innings has been deviated from its average. Now minus 2, minus 1, plus 0, plus 3. Minus 1, minus 2, minus 3, plus 3 will get cancelled. So it will be absolutely 0 deviation because you have just distributed all innings by average, that is also same. Or if you look at the deviation of each innings from the average, then the summation or the sum of the deviation across all the innings will always be 0. So so that what is the meaning of deviation is 0. That means that if I replace all the innings by 3 also, then also same. If I having the individual score, then also same with respect to total number of runs. Now if I want to write through a formula, right? Now we have seen that 4 innings were there. So total number of innings, inning number 1, 2, 3, 4, right? And the runs he has scored is 1, 2, 3, 6. So if I want to take averages, how do I do? I take total sum, that is in this case it is total runs, divided by total number of events, that is in this case total number of innings, that is total event or total objects. events, whatever it is, right? So the average is total sum divided by total number of events. So this you have to understand. So that means that in this case total sum is 12. The total number of innings or the events is 4. So average will be 3, right? So if I replace two things we have understood. One, if you replace all the innings by the average, still the total remain same, right? Whether it is humanly possible to replace all the innings, that is a different thing. For example, if somebody has scored 1, 2, 3, 4, right? That means the total runs is 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, right? In the 4 innings. So per innings, how much it will come? 2.5. So if I replace all his innings by 2.5 runs, 2.5 runs, 2.5 runs, again the sum will be same. However, can you really replace as a 2.5 runs? Either you can have 2 runs or 3 runs, right? But for our calculation purpose, for our understanding purpose, if I can replace all the innings with 2.5, that is average, still the total will be same. It is a very, very important concept to solve few of the problem where you do not need to apply the formula, right? All right. So now we see another concept of statistics, which is called median, right? Now what is the problem with this mean? Now you understand the problem with this mean. Now there is a batsman who has scored 1, 2, 3 and let's say 6. Okay. Now this is his scores. Okay. So that means that in each innings he is playing in a single digit. Now one fine day he got a very weak team and he somehow played, a best match of his career, and let's say he has scored, let's say 108 runs. Okay, I'll take it as 108. Right. So now that means that this was 12 plus 108. Total it would have become 120. Total innings is now 5. So that means that each innings he has scored 24. So that means that now it looks like his batting average is 24. That means that if I replace all the innings by 24, then also 120. But if you look at it, most of the innings he was just a single digit. Just because of those one innings, his average has increased so much that all of his average, 1, 2, everything has become now 24, right? So that means that the outliers, which can be a maximum. Let's say another person who has scored, 100 in first innings, right? Next innings he get out duck. That means that his average will become 100 plus 0, that is 100, by 2 will be 50. Suddenly his average has been from 100 to drop to 50 because of this outlier. So that means that whichever is basically either you are having 2 less, 1 item or 1 item too high, then what will happen? The average will start moving towards that number. That means that if you are having average, here in this case average was 3. Now, since he has scored 108, that is the outlier, the average also start moving towards higher number, right? So that means that it will increase. Because of this one innings, it has increased how many times? 3 to 24. That means that the increase has 8 times of his average has been increased by 8 times. So, right. So, because of this one outlier innings. So, that is why mean may not be useful to get a clear picture. Now, if I want to take this as, more better way of understanding, let's say there is a, an area where most of the poor people live. Everybody is earning, let's say 1,000 rupees per month, one person. Another person, let's say earning 2,000 rupees. Another person, let's say earning 3,000 rupees, right? Another person, let's say earning 4,000 rupees. So that means that if you just take average of all of 4, it will be 10,000 by 4 will be 2,500. It's just as good as saying if all were earning 2,500, that is also same. This is also same. Now imagine that in that one street, if there is a very rich person, right, who is earning, let's say, let's say 9,90,000, okay, per month. Now what will happen? This 10,000 plus 9,90,000, so total will be 10 lakh will be the total income of the 5 families staying in that road. So that means per family, if I calculate, so that is average is what? Total amount by total number of families in this case. So 10 lakh by 5, it will become 2 lakh. So it's as good as saying that everybody is earning 2 lakh. Right now, if you are thinking that you are taking some, data statistics to, formulate some policy, and if you are coming up with this data that, this gully has basically a street where people are earning 2 lakh per month as an average. So then the whole idea will be defeated. You will not be having a clear picture. So because why this has happened? Because of this one outlier. So mean can be either taken down or the average can be taken up by the outliers. So that is why this is not a very good way to have a statistics where you are formulating the policy and all. So what would be a solution? That leads to a next concept, that is median. So median, what does it say? Median, it just says exactly what are the center point that lies. So what it says, let's say if you are having, 1K, 2K, 3K, 4K, and let's say 4 people. Now what it says, or let's say first we'll take 9.9 lakh, right? Now what it says, don't worry about taking the averages. I want to see where the middle person lies. The middle person, if I arrange all of them in ascending order or a descending order, whoever is the middle person, that shows the picture that half of the people are above him, half of the people are less than him. So that means that he is at the middle. So if I can see the middle number ka salary, middle number ka income, that gives you a better picture, because you know that 50% will be more than him, other 50% will be less than him. So that means that let's say in this case, out of 5 people, who is the middle person? 3K. So I can say the median income is 3,000. That means that 50% of the people who are earning are less than this person, that is 2 people, 1K, 2K. Another 2 people are earning more than this. So this will give me an idea where the middle person lies. So that is a better way to understand the kind of income that you can expect, rather than having an income of 2 lakh for each. It says that the middle person is earning only 3 lakh. So for these things, instead of taking mean, it is better to take the median. All right. Okay. Now the second question comes, sir, it is easy because there are 5 terms. I have taken the middle term. What if there were only 4 even number of terms, right? For example, if there is 1, 2, 3, 4, 5, 6. How do you take median? Because now there is no one middle term. Now you know that this is 50%, this is 50%. Now these 2 numbers are middle. Exactly the center of them are actual middle. So 3 and 4. Middle of 3 and 4 is what? 3.5. Right? Similarly, if it is 2, 4, 6, 8, 10, 12. Right? What are the middle 2 terms? These are the middle 2 terms. So where will be exact center? This is the middle. This side 3, this side 3. So if this is 6, this is 8. Then the middle term will be between 6 and 8, that is 7. Exactly between 6 and 8. Right? So that is your median. Right? So sometimes the data might not have given in a ascending order. They would have given you 2 first, then 3, then 1, then 4, then again, like this, right? Then 6. Right, like that they would have given you then 5, like this. Then your job is to arrange them in ascending order first, then take the middle term. Okay, so that is how median is calculated. All right. Okay. Now let's go to the next concept, that is mode. Now these 2 are fine. Now you imagine a situation. You are having a, let's say, let's say a shoe shop, right? So now where basically you are having a shoe shop where you are having different sizes of shoe, let's say 8-inch ka, 9 and 10, right? Now let's say based on, now you want to go to the inventory and keep reordering from the factory. Let's say now you are a shopkeeper. Now how do you look into it? Let's say this is the size and this is the number of shoes sold per month. Every month I am ordering from this thing, right? So let's say 8 is a common size or 9 is a common size, let's say, right? So 9 may, let's say 100 pairs of shoe has been sold, right? Now 8 may, let's say 30 pairs have been sold. Now similarly 10 may less, let's say 20 pairs have been sold for that particular month. Now if I want to order next month, if I just take mean, how much every size has gone, then 1000 plus 30, 130 plus 20, 150, total 150 pairs of shoe has been sold in that month. And if I take by 2, by 3, so each size I have to order 50, which will not make sense, because whatever that I have already ordered, let's say initially I have all of 100 in my inventory. That means that already only 20 has been sold. 80 is still left with the 10 size shoes. Similarly, out of 100, only 30 has been sold, and still 70 is left in the size 8 also. Now that means that 9 has been completely got emptied, because 100 was there before and 100 has been sold. So I cannot just take average and reorder 50 50 50 each time. It will not make the sense also. So what I am supposed to do? So I will see which one has been mostly taken, highestly repeated. So that means that I will have my account book. One day 8 inch has been sold, then 2 9-inch has been sold. Like that, which inch of the shoes that has been sold maximum time? So that is 9-inch. So that means that the mode will give you what is that the demand is highest for, and then you can plan accordingly. So the mode is nothing but among the given data, which is that data which has been repeated maximum number of times, right? So that will make you to understand. Let's say I am taking an experiment, right, and see that in a chemistry where I am putting a drop of chemical to change one color to other color. Now many a times what will happen is for some miscalculation, sometimes the data might not be exact, a little less or little more of the kind of chemical that you are putting. So it can be a little more or less than what exactly it is required. In this situation, what will happen if I take average also? It is not correct way to look into it, because the accuracy is very important. So what I will do, once I repeat my experiments, which experiment or which type of that chemical which has been during which basically it has been become correct for the maximum number of times. So where I will look into the mode, so where I see that maximum number of times which has become the truth. So that is basically mode, which will show you what is the maximum frequency of one event that is occurring many times. So once you get that, that will give you a broader idea. So that is your mode. What is your range then? Right? The word range just says that it is nothing but among your all the data, what is the lowest, what is the highest. So that is between these two numbers, all other numbers are available. So this lowest and the highest number is a range. Range is not one number, but it is a range, that is from upper to lower, where your all data has been there, right? So that means that if you are having 1 2 3 4 5 6, then your range is 1 to 6. All your scores are between 1 to 6. So the range is between the highest and lowest data, right? Right, that's it, guys. So now it is about thinking logically, right? So if small things we will do, right, understand it, because in many a small concept you have to just understand these basic things, right? So as I told you, what is the one way is always replacing all the terms or assuming all the term as average only, so that whatever the changes happen, you can understand that. Second, let's say if I want to take average of two numbers, right? So if somebody says you that this number is 200, another number is 250, right? Now I want to take the average. So many times what we will do, we'll add 200 plus 250, because total sum, this is a formula that we have mugged up. 200 plus 250, that is the total sum, that is 450. Then since average is 9, 450 by 2, then you will write it as 225. All right. So this is your average. But do you really need to add this? What is the average? Average is a center number from where the deviation should be 0. That means that if I take 200 and 250, I have to find a middle number between these two. If the 50 is gap, what is the middle number? 25. That is, this difference is minus 25. This is plus 25. This will be your average. So that is the exact middle of 200 and 250, that is 225, will be your average. You don't need to calculate, add and then divide. You just imagine that your deviation, here minus 25, here plus 25. Deviation in the average should be what? From those numbers, from the average, total deviation should be 0. So that means that I want this side the same number, this side the same number. So exactly center if I take. So I can directly say that the gap is 50. So if I divide 50 into 25, so by 2, then it will be 25. So that means that this will be 225 is the average. So that means that if 100, if 80 and 110, I need to take an average. Then what you are supposed to understand, you don't need to add 190, first 110 plus 80, 190, then divided by 2, then 190 divided by 2, 2 nines are 18, 1 will remain 10, so 2 5s. So you don't need to do this, right? So all you have to do is the gap is 30. So if the gap is 30, I want to distribute this 30 into two equal parts, 15, 15. So exactly the middle number. So that is this side 15, this side 15. 95 will be your average. So totally difference is 30. So I have divided into 15, 15 parts. So that means that this 15 part will be 95. Minus 15 plus 15. This is one way to look into it. Right. Now there another problem is, kind of this problem where you understand the simple problem. If I say that, a person has average of, 10 runs, or he has scored, his average score is, let's say, 10 in a test. Total 4 tests he has scored and his average is 10. Now in the 5th test, he has to score how much so that it has to become, let's say, 20. So what do you have to understand here? So now in this kind of problem, now you don't know his 4 individual scores. All you know is his average was 10. But if you, what that you are already knowing is, if the average is 10, so if I replace all the innings by 10, all the score tests by 10, right, still his total is not going to change, because now average they have given 10 and total number of tests that they have given 4. So average is what? Total score divided by total number of tests. So total score we don't know, but total test you know 4. So that is 10 is equal to x by 4. Our total runs, our total score is equal to 10 into 4, that is 40. Right. So total runs is, total scores is 40 here. All right. So this is also same. If I visualize that in first 4 tests, he has scored 10, 10, 10. We don't know whether he has scored 9 and next 11. We don't know, but we are still assuming that all score, if he has all tests, if he has scored 10, that is also same. Right? Because here also total is 40. 10, 10, 10, 10, first, second, third, 4. Now what they are saying, in the 5th test, how much he is supposed to score so that the total becomes, or the average becomes, let's say, 20. Right? Now you imagine it. Now the 5th, how much he has to score? Now, how much he has to score? If he wants to score 20 average, that means it is as good as saying he has scored 20, 20, 20 in each test, right? Now, that means that he is not only scoring 20, but he has to make this 10, 10, 10 also to make 20. That means that, this has to be increased by 10. This every 4, previous 4 tests also given 10, 10, 10. So, that is 40 plus this test again 20. So, that is total how much he has to score? He has to score 60. So, now if you see 40 plus 60, total is 100, and out of 5 tests if I see, average will become 20. So, what I have done here, rather than, there are 2 ways to do it. One, initial total score, average was 10, total number of tests that he has written was 4, the total score was 40 before. Now, they are telling that after 5th test, his total score become how much? Our average has become 20. So, average has to become 20, that means the total score is nothing but average into after 5th test, his total number of tests is 5. So, this is basically 100. Now, that means that how much extra he has scored, this difference, that is 60. This is one way to do it. But here every time you have to take the number. Other is visualizing. How I am visualizing? I am thinking that before he was scoring all 10, 10, 10. Now, in the first 4, now he is scoring all 20, 20, 20. That means that how much he extra scored in the 5th. One, he has scored this 50. In the 5th, he has scored 20. Plus, in all his previous, he has increased 10, 10, 10. So, with the 4 innings, if you want to increase 10, 10, 10, or in the 4 test, if you want to increase 10, 10, 10, then, for 4, 10, 10, 10 means 4 times 10, that is 40, plus 20 here, that is 60. All right. So, that is how you will replace and do the calculation. Now, we will move to the problem that has been asked in PYQs. Right. Now, there is the concept of weighted average. This I will be covering in the next video along with mixture and delegation. So, it will be mostly useful for mixture and delegation. Let's understand only this concept till now and try to apply this, much more than enough, but only your thought process has to be understood here. Right. First, the average weight of ABC is 40 kg. Average weight of BDE is 42 kg. Average weight of F is equal to that of B. What is the average weight of A, B, C, D, E, F? Right. So, if I want to take the average of all 6, I should know the total of all 6. and then total divided by total number of people or the events here, your object here is 6. So the total weight divided by 6 I have to do. Right, now how do I find the total? First thing I have A, B, C, and they have told that average is 40. So can I say that if I replace all 40, then the total will be 120, right? Because the average, if I replace all the weight individually, I don't need to know the weight. If I just replace all of them by average, then the total remains same. So that means that A, B, C, A plus B plus C is how much? 120. Similarly, they have told that B, D, E, B plus D plus E. How much will be total? If average is 42, total is, if I replace all of them by 42, for example, then what will be the total? Total will be 42 into 3, that is 126. Right? Now, however, what they have given, here we are not having F here. ABC is having, D and E is there, but F is not there. But what they have told, weight of F is equal to that of B. So that means that instead of B, if I replace F, because B and F are same. Now what is happening? D plus E plus F. Right? So that is 126. Now ABC is 120, DEF is 126. So A plus B plus C plus D plus E plus C will be 120 plus 126. That is nothing but 246. Now if total sum of the weight is 246, how many people are there? 6 people are there. If I want to take the average, it is 41. 6 fours of 24, 6 ones are this. So that will be 41. A very simple problem. Next, there are two classes, A and B, having 25 and 30 students respectively. Now in class A, highest score is 21. So I will write it here. Class A, what is the highest score? Highest score is 21. Lowest score is 17. Next, in a class B, highest score is 30. Right, and the lowest score is 22. Right, now total number of students, if I want, from class A there are 25 students, and from class B there are 30 students. Now this is the data that has been given. Now if you think logically, what is the average? Average, if you want to have a zero deviation, so average has to be between the lowest and the highest number. So that means that if I am having 1, 2, 3, 4, right? So the total was 10. What was average? 2.5. So that means that it will never be more than 4. Similarly, it will never be less than 1. It has to be between, somewhere between these two numbers, so the deviation remains equal, right? So that means that average always lies between the highest and the lowest number. If all numbers are same, that is 1, 1, 1, then average itself will be the number itself will be the average, whichever the number. So otherwise, if there are different numbers, the average will always lie between the lowest and the highest number, because you have to have the equal distribution later. So the deviation should remain 0, means half of the number, or the numbers, whatever the number that you are having, the deviation from that sum of that deviation should be finally 0. That means that number should be lying between, somewhere between these two numbers, right? So if I am having 1, 3, let's say 10, right, and 1, 3, 4, let's say 8, right, 1, 3, 8, right? So that means that 4 plus 8, 12. Average is what now? That is 4, right? If average is 4, that means that if I replace all 4, that is also same. If you see the deviation, this is -3, this is -1. Total deviation is -4. Here 8 is 4 more than 4, that is +4. So average deviation will be 0. That means that the total deviation will be 0. So that means that when it can happen, when sum of numbers are more than the average, sum of the numbers are less than the average. So that means that the average has to lie between the lowest and highest number. Okay. Now that means that if I am talking average in this case, it will be somewhere between 17 to 21. Average in this case, it will be between 22 to 30. Right? So between, anywhere it can be between, depending upon which kind of students are more. Right? Anyways. Now, in class B, this is okay. Now, 4 students are shifted from class A to class B. Class A to class B, 4 students are shifted. Now, consider the following statement. Average of class B will definitely decrease. Point number 1. Now the average score of the class A will definitely increase. There are two cases. Now first we will see the first case. Now in class A, since 4 people are moving, there can be two cases. One, the highest scoring, let's say the best, the worst case for class A, the best case for class B is what? The highest scoring student of class A are moving to class B. That is one case. Or there can be a possibility when the lowest scoring students of class A can move to class B. Two possibilities. Now first imagine that highest score students are moving. So that is 4 students who are scoring 21 are moving to class B. Then what will happen? Now since this is the people who are moving, now new lowest score, initially the lowest score of the class was 22, now the lowest score will become 21. So that means that because this highest scoring itself are scoring 21 marks, so they are moving here. So that means that the lowest score of class B instead of 22 becomes 21 now. As you are having more lesser and lesser scores, then what will happen to the average? Average will also decrease. So class B average will decrease in first case. Now second case, that is when you are sending the worst performing students or less scoring, least scoring student, that is 17. You are sending the people who are scoring 17. That means that now the new low score or the least score of class B becomes 17. Still the average will decrease because of this. So that means that in any case, if you send the best performing students also who are scoring 21, which is still lesser than the least scoring student of class B, or if you are sending a student who are scoring least score of 17, which is also less than least scoring students of class B, so automatically the average will decrease in both the cases. Yes, first statement is correct. Now let's see and understand what will happen to class A. Now let's say you are sending the best students of the class. No, think logically. If you are scoring the best scoring students, right? Or it's as good as saying that Ambani, Adani, the richest people are sent out of the country. What will happen to our average income? Right? Of course, it will decrease. Right? Now, if you are taking of the poorest of 4 people and sending them somewhere, then what will happen to your average? The average will increase. So it is just like in that way, right? So you are saying here that if I am sending the best students, that is 21 scoring students, if they have been sent, then it will affect the average of the class A because they were high performing student. Overall average of class A will decrease. But if you are sending the 4 worst performing student that is scoring 17, then what will happen? Their average will increase. So that means that their average will increase or decrease of class A depends upon who they are sending. Whether it is for best scoring, then it will decrease. Worst scoring, then it will increase. So definitely increase is not correct. Whether it can increase, it can decrease depending upon which student. So this is not correct because as I have already previously discussed, definitely means what? Always. But class B ka average will definitely decrease because even if you send the best student also, they are still not scoring more than the lowest scoring student of class B. So first is correct, second is incorrect, answer is one only. Now let's go to this I will give it to you because this is more of a mathematically calculating problem. What is the question? Runs scored in the first innings, balls faced in the first innings. They have given 4 players ka. Similarly, runs scored in the second innings, balls faced in the second innings. Now question is, who is the fastest run scorer in the test match? How will we checking the fastest run scorer? For each run, how many balls he has taken. Whoever taken less number of balls for each run, that is one way of looking into it. Or per ball, how much run he has scored. Whoever has scored more runs per ball, who will be the fastest run. So that is a manual calculation, right? So that is the logic behind it. Please you understand that and do them and put the answer in the comment, whether it is A, B, C, D. All right. Now, the average score of a batsman after his 50th innings was 46.4. After 60th innings, his average score increases by 2.6 runs. What was his average score? Not total score, average score in the last 10 innings. Now, I will do it from the point of, understanding through this, that is, regular formula based method. And second, we will do it through the visualization method. So, right. So, over a period of time, we have to move towards the visualization kind of method. Right. So, now let's take this 46.4, right? So, now you think that total number of innings is 50, average is 46.4. Now, next, Total after 60th innings means total number of innings is 60. Average is increased by 2.6. So how much it has been increased? 46.4 plus 2.6. That will be 49. Now that means that what is the total run? After 50th innings, what was his total run? After 60th innings, what was his total run? That is the first way. So what is the total run? Total run is nothing but average into total number of innings. That is 50 into 46.4, which will be 2340. Right. Now, how do you calculate this? Again, see, these are some basic things that you should be knowing. You should not be having, calculating 4 into 5, 20, then, doing this calculation. 50 can be divided something like this. 100 divided by 2. If it is 5, then I can write it as 10 divided by 2. Now what will happen? So this will become 100 divided by 2 into 46.4. So 46.4 into 100 is 4640. Right. So now 4640, right? So sorry, this is 20, right? 4640 divided by 2. What will happen? 2, 1, 2, 2 za, 2, 3 za, 2, 2 za, 2, 0. So rather than multiplying it 50 into point, what I can do, I can multiply with 100. So I can just replace it as 46.4 into 100 will be 4640 divided by 2. So that then you can do it. So if similarly 46.4 into 5 is there, then what you can do? 46.4 into 10 by 2. So because of this, basically it will become 46464. 46.4 into 10 is 464 divided by 2. Then it becomes easy. 2 2s are, 2 3s are, 2 2s are. Like that you can just do it. Right. Similarly, 500 is there, 1000 by 2. Like that, you can just use it. Right. So that is one way of looking into the things. Right. But anyways, so my God. Total runs. So total runs is 2320. This is 1. Now I want to do it 49 and total innings is 60. Now what will happen? 49 into 60. So 6 9s are 4. Similarly 54. 5 carry. 6 4s are 24. 24 plus 5 is 29. So this will become 2940. Right. So that means that how much extra he has scored in this 10 innings. Because now they are not asking his present average. They are asking 10 innings average. First I have to score how much he has scored in 10 innings. Then number of innings is 10. So you have to divide it by 10. So the total runs he has scored is basically 0 minus 0, that is 0, 4 minus 2, 2, 9 minus 3, 6. So 620 runs he has scored in the last 10 innings. So average is 620 in the last innings. Per innings is how much? Per innings is the average. Right? So that is 620 by 10. 62 runs is average. So 62 is this average. So here there is this calculation. Right? So now what is the visualization method? Second method, visualization, which I always prefer to follow, because that will not only help you to even if the problem has been changed, then it gives you a visualization, so it becomes very easy to solve. What is the first thing? First 50 innings he has scored. Let's say he has scored like this, 50 innings is there. His average is 46.4. Now we know that even if you replace the average for all the innings, total run remains same. So I can say that he has scored 46.4. 46.4, 46.4, like that for 50 innings also he has scored 46. Now math, realistically it is 46.4 runs is not possible, but we are taking from the imagination point of view. If he had scored 46.4, then also the total remains same. Now what is happening after 60th innings? His new average has become 49, right? So that is 49, 49, 51 innings, 52 innings, like this up to 60. So 49, 49. Here also his all innings, if I replace by 49, still it should remain same. Right? So that is in all 60 innings, if it is replaced by 49, that is also same. That means that if you look at now, this 10 innings, that is 51 to 60, 49, 49, 49. That means that this part is 490 because 49. Now if you look at it, how much extra he has scored? He has scored 2.6. He has not only scored this 490, for previous innings also he has given 2.6, 2.6, 2.6. Like that, for how many innings he has given? For 50 previous innings. For each innings he has given 2.6 extra. So that will be, again as I told you, 100 into 2 divided by, 2.6. That is 260 divided by 2, that is 130. So 130 extra he has scored, or he has given for the previous 50 innings, because it was 46.4. He has given 2.6, 2.6, 2.6 for 50 innings. That is 130. In this 10 innings, 49, 49, 49, that is 490. So 490 plus 130 will be 620. Here there is no 2340, 2950. That calculation is not there. All you have visualizing is, if you have scored 449 in each 60 innings, that is in the last 10 innings anyways 49. Previous innings, for how much extra he has given. 2.6 for 50 innings, that is 130, plus last 10 innings 49, 49, 49, that is 490. 490 plus 130 will be 620. If 620 in the last 10 innings he has scored, then in the last innings how much he has scored, or in this, total average is basically 620 by 10 innings, that will be 62. Okay, now we'll do one more problem, you understand it better. Right, this is a logical problem. In a class there are 3 groups, A, B and C. If one student from group A and 2 students from group B are shifted to group C, right? So in a class, imagine that there is a class where there are 3 rows, one group A, group B, group C. One student from group A has been sent to group C. 2 students from group B has been sent to group C. Now, what happens to the average weight of the students of the total class? Right? So it increases, decreases, remains same, no conclusion can be drawn. Now this will give you a conceptual clarity. Right? So think about it and put the answer. Next, the average score of 100 students are given to be 40. It was found later that marks of one student was 53, which were misread as 83. What is the corrected mean marks? Right. So what is the question? 100 students are there. Total number of students is 100. Average marks is 40. Now, what is the problem? Later it has came to know that for one student, instead of 50, he has scored 53, but they have marked it as misread as 83. Right? And the average has become 40. Right? Now, what is the new average if I want to correct it? Right? So, first we will understand what was his total score in the previous way. What was his total score? Total, the total number of students is 100. Average was 40. So, total score is basically 100 into 40. So that means that 4000. Now what is this problem in this 4000? Instead of 53 you have read 83. That means that how much extra you have read? 30 extra you have read. So 30 extra you have read. If you have read it correctly, then 30 should be less than the total now. So that means that the actual total should have been 3970, because you have read 30 extra. So that means that actual total is 3970. Total number of students remain 100. What will be the average? 3970 by 100, which is 39.7. Right. So take the total, reduce that extra, and then that is one thing. Or if you want to think logically, as we have done previously, we have visualized that in all 100 students has scored 40, 40, 40. Right. Now in this average, what is happening? 30 has to be reduced. Now this 30, whatever that extra has been taken, distributed among how many people? 100 people. So if I want to divide this 30 by 100, from each student will lose 0.3. So each 40, if they were having 40 before, if I lose 40.3, then 39.7 will be the new average in any ways, right? So a student on her first 3 tests received an average score of n points. If she exceed her previous score by 20, that is in the 4th, she scored 20 more than her previous test, right? Then what is the average score of the first 4 tests? Right? Now you think logically and do it. If you are getting confused, assume a number. The n point is 5, 10, whatever the number, and then you calculate whatever the way you want to do. N plus 20, n plus 10, n plus 4, n plus 5. This is also a PYQ that you have to put the answer in the comment box. Now these 2 problems I will do, and then I will end up your chapter. Now what is the problem? A batsman scores 23 runs, increases his average from 15 to 16. That means that his previous average was 15. When he scored 23 runs, his new average has become 16. Okay. Find the runs he is supposed to, or he wants to increase the average to 18 in the same match, not in the next match. If he is supposed to increase from 15 to 18, how much he would have scored, right? So now how do you look into it? right? So that is the problem here, right? Now you imagine, you don't know how many matches he has played. Now let's understand. One, again, traditional method. Second, visualization method. Now you will understand the difference, right? Now let's say the traditional method. What is that? Total number of matches. How much he has played? We don't know. I will put it as X. What was his average? It was 15. So what was his total runs? Total run is average into total number of matches, that is 15 into X, 15X. Now, in the next match, he scored 23, that is one data. Now, what they are telling? They are telling that his average has become 16. That means that since he has played this match, previously if he had played X match, now it will be one more than the previous match. That will be, he has played X plus 1. Now what is his total? If you look at 15X was the previous. In this innings, how much he has scored? 23. So that means that total runs, if I want to see total match into average, that is 16 into X plus 1 is equal to 15X plus 23. You can write it like this, right? So that means that 16X plus 16 is equal to 15X plus 23. So that means that if I want to further add, right, if I send this side and if I send this side, right? So that means that 16X minus 15X is equal to 23 minus 16, or X is equal to 7. So what is X? Total number of matches, right? Now what is the question they are asking? He wants to increase it to 18, right? So now you know that total number of matches is 7. Okay. Now in the next match, instead of 16, how much he has to score? Next match total number of matches is 7 plus 1, that is 8. Now average he was to increase is how much? 18 into 18. So that will be basically how much? 144, right? So total runs he was to make is 144. During this match, he was having 15 average, 7 matches. He was having 15 into 7, total runs was 105. So his score was 105. Now he wants to make it 144 so that average can increase. So now that if you look at it difference, how much extra he has to score? 39 he has to score. From 105 to 144, he has to score 39 runs. That is your answer, right? So now if you have seen how much calculation is involved, right? So that is a more of a confusing kind of thing, and if you miss something, then the entire game plan will affect. Now let's understand how to do through visualization. First, what is that they are saying? Previous average is 15. That means that 15, 15, 15, like that, you know, how many innings I don't know, right? X innings he has played. 15, 15, 15, 15 his average was. So if I distribute all his matches also 15, the total run is not changing. Now what is happening? In the next match, that is X plus 1 match, what he has done? He has scored 23. So he has scored 23. So what has happened to the average? Average has become 16. So that means that if I replace all his previous innings, including this innings, with 16, then also his total runs should remain same. That means that it is just as good as saying that 16, 16, 16, 16, 16, 16. Now, if I see, he has scored 16, kept 16 as an average for this inning, and he has also given 1, 1, 1, 1 extra for the previous innings. So how much extra he was having out of 23 if he kept 16 for himself? 7 extra he was having. So if he is giving 1, 1, 1, 1, 1 for each previous innings, that means that how many innings he can give 1, 1, 1 for 7 innings. So now I clearly know that he has played 7 innings before, right? So if he has scored 7 innings before, right? Now let's say if he wants to make it 18. So 18 ko what he has to do? First he has to keep 18 for himself. Then he has to give 3, 3, 3, 3 for previous 7 innings. For 3 into 7, 21 runs he has to give to previous innings, and 18 he has to keep for himself. 21 plus 18, 39. It's that simple. Right? No calculation, only visualization. So what we have done here, if 16 was there, he is keeping 16 for himself as a new average. Then he is also increasing everybody's average. He is giving 1, 1, 1 so that their average or their innings average also can be increased. So the previous innings 1, 1, 1, 16, 23. So 23 means 16 he is keeping. 7 runs he is giving 111. That means that for how many people he can give 7 rupees, 1 rupee to each. How many people you can give? 7 people you can give. Similarly, you have 7 runs extra. So, and you have to give it 1 for each inning. So, for how many innings you can give? 7 innings. So, previously there were 7 innings. Right. Now, this is the 8th inning. Now, if the same question is if you want to give 3 rupees extra, right, with the average of 18. So, that is 18 you are keeping. Then you are giving 3 for 7 innings. So, that is 21 plus 18 you are keeping as a new average. So, 18 plus 21, 39. That's it. Right. Now, the last problem. Here you have to observe the question is in the same match only, not in the next match. So, that is why we have to do instead of 16, if he wants to make it 18, how much he has to do. Next match means that is a different kind of problem, right? So, now we will see the last problem for the day and we will wind up. The average score of a batsman in certain number of matches is 43. By scoring 50 runs in the next match, his average improves to 44. What is the number of runs he has to score in the next match again to further improve his score to 45? Right? Now, I will do with only one method, that is the visualization method. Right? I will not go with the traditional method. Now, what is the problem? They are telling the average, total number, how many certain number of matches. That means the total number of matches they have not given. But they have told that 43, 43, 43. So, his average was 43. So, in previous innings, we don't know. X innings he has played, right? In each innings, let's say he has scored 43. Because if I replace all the innings by, equally with all the averages also, then still total remains same. So, it is 43. Now, in the next innings, what he has done? He has scoring 50 runs. He improves his average to 44. That is, in the next match, he has improved his score to 44 average. That means that he scored 50. That is, he is keeping the average 44. So, that means that, how much extra he is giving? 111. So, he has a 6 runs extra out of 50, keeping 44. That means that 6 extra to increase the average each innings by 1. For how many innings he can give? For 6 innings he can give. Because 6 runs are there. For each innings he is giving 1. So, that is basically if he wants to make it 44, 44, 44, this that for how many innings he can give? For 6 innings he can give. Right, because 6 extra he was having. Now, what is the next question? So, that means that including this match, how many matches he has played? He has played 7 matches now. Now, in 8 innings, how much he has to score so that his average becomes 45? That is, he has to keep 45 for himself and for all the remaining 7 innings. Now, not 6 innings because including this innings, now we have played 7 innings. So, in the 8th innings, he is keeping 45 for himself. How much he has to distribute? He has to distribute 1 for previous 7 innings. So, that is 1 and 7 innings, 1. That is extra 7, keeping 45 for himself. So, 45 plus 7 will be 50. So, that means that in how much he has to score in the next innings to increase his further average by 45, 52. Alright. So, this is your question. So, the 3 problems that has given to you, please go through them and solve them. And if you are able to solve them, it's good. Or if you are try and if you are not getting it, please comment. And if you are not really participating in the next video, I will just make the video. I will not give you any PYQs to solve so that you can I just feel that if you are participating, then it's worth giving the question of the PYQs. All right. So with that, if you have liked the video, please like the video, and let's see you in the the next concept of weighted average, mixture and delegation problems on edges in the next video, related concept to the averages. Okay. See you guys. See you in the next video.